This is what this program's about, a substance you can't see. Natural gas is mainly methane with a small amount of hydrocarbons and inert gases. It's not toxic, but it can burn up the oxygen in the air and so create conditions that could suffocate. It's got carbon in it too, and if that's not completely burnt, carbon monoxide can form, and that is very poisonous. And always, of course, there's the possibility of ignition and explosion. That's why anyone involved in any sort of work on gas appliances has to pass a training course to prove that they're competent to deal with such a potentially hazardous substance. This BPEC Open Learning course is designed to cover certain elements of gas safety which you need to be familiar with to follow the approved code of practice. This program will give you a brief overview of some practical aspects of the work and should be used together with the manual. So, welcome to the course. You'll be taken through safety regulations, procedures, and the British standard specifications that you'll need to know to do the job properly and safely. With an open learning course, you work through the units at your own pace, in your own time. You'll find self-assessment questions and tutor-marked assessments. These will check your progress as you work through the various modules. In each module, answers to self-assessment questions are given, so it's easy to cheat. Remember, though, the only person you're cheating is you. At the end of the course, which should take about 37 hours, you'll do a 3-hour assessment at a centre, and as long as that's successful, you'll get a BPEC competency card. All you'll need is the open learning package, some paper, a pen, a folder, a video recorder, a television, and a phone. If you've opted for tutor assistance, you'll find all the literature you need, like details of regulations and British standards, at the assessment centre. That's also where you'll have the workshops and tutorials, if they're required, to reinforce what you're learning. As well as professional skills, you'll have to learn about the various gas safety regulations and your responsibility as an installer. These rules are very important, and for your own sake and the safety of all the people your work could affect, make sure you know what they are and that you stick to them. So, good luck with the work. If you're ever in doubt about anything, either go over the manual again if you're using self-assessment, or if you're being tutor-assisted, just ask. For combustion, we need 3 things: oxygen, fuel, and ignition. But they can produce different types of flame, good and bad. If the gas-air supply is faster than the flame speed, you get flame lift like this. And if it's slower, you get light back. So for flame stability and good combustion, it's important to get the right air-gas ratio and flame speed. There are 2 ways of mixing air and gas. In a post-aerated flame, neat gas is supplied to the burner, and all the air for combustion comes from the surrounding atmosphere. This is called secondary air. In the domestic market, though, it's a pre-aerated flame that's most common. As gas is injected, it draws primary air in through a port and mixes with it. This obviously gives greater control over the shape and quality of the flame. Changing the balance between the amounts of gas or air supplied will affect the flame like this. A smaller injector means less gas and more air. That produces a smaller flame like this. Bigger air ports and loosening the aeration screw have the same effect. If you increase the ratio in favour of gas by having a larger injector, smaller ports, or by tightening the aeration screw, you get a longer, slacker flame. This is the sort of flame that's produced by a balanced mixture. In pre-aerated flames, there are 4 zones. The first is the unburnt zone, where the air-gas mixture hasn't yet reached ignition temperature. The second is the flame front, where the unburnt mixture and the flame meet. The mixture is moving at the same speed as the flame, and so you get ignition. The third zone is the hottest area of the flame. It's the reaction zone, where the gases are partially burnt. And finally, there's the outer mantle. It's here that combustion is completed by air diffusing into the flame. This is where you'll see the first signs of lack of oxygen, when the tip at the outer mantle becomes yellow and ragged like this. For every cubic metre of natural gas burnt, 10 cubic metres of air are needed. The reaction produces 1 cubic metre of carbon dioxide and 2 cubic metres of water vapour. The gases produced by combustion are, logically enough, known as POCs, products of combustion. There are also about 8 cubic metres of nitrogen in the flue. This has come from the 10 cubic metres of air. When you're installing or servicing appliances, you must check how the products of combustion will be removed, the availability of air, the means of ventilation, and the actual heat input. There are various factors that can lead to incomplete combustion. Not enough air, over or under gassing, impingement of the flame, and so on. Any of these things can cause conditions in which gases are cooled to less than their ignition temperature. That means that some of them won't be completely burnt, and so you may get products of incomplete combustion. There are set combustion standards which work on the ratio between the amounts of carbon monoxide and carbon dioxide produced from a flame. This ratio mustn't be more than 0.02 to 1. Readings of the gases are taken by using equipment like this. This is the Draeger apparatus. Basically, it's a pump with neoprene bellows. It indicates the concentration of a particular gas by discolouring crystals. You can use the tubes to sample singly or combine them, in which case they're called simultan tubes. There's a set procedure to follow. First, check that the sampling probes are complete and clear. The screw should be tight, the bellows sound, and the pump should be working. Periodically, you should also check that the filter's clear. And that the tubes are within their expiry date. The appliance should be turned on for at least 5 minutes to allow it to warm up. Now the apparatus is purged by putting the sampling tube into the primary flue, connecting the pump to the probe and operating it 3 times. You then fit the spring clip, disconnect the apparatus, and remove the tube. To sample for carbon monoxide and carbon dioxide simultaneously, take the combined or simultan tube and break off its fused tips. Put it into the nozzle of the pump with the arrows pointing towards the pump. Now connect their other ends to the rubber tubes on the probe assembly and remove the spring clip. Squeeze the bellows to the stop position and let them expand fully. Now you can read off the position of any CO or CO2 discoloring against the scales. Now, by using this formula, it's easy to calculate the ratio between CO and CO2. So there you have some of the basics of combustion. Whenever you're installing a gas appliance, you must observe all the legal requirements. This course will take you through them, but you should always be aware that changes might be made to them, so keep checking that you know the latest regulations. Your manual gives more details of the types of flue available and their construction. The products of combustion we mentioned have to be disposed of safely. That's what the flue does. It works by moving the gases away from the burner by using either thermal convection, a natural draft, or an electric fan. It's then called a forced draft. There has to be enough of a draft to move the combustion gases, enough heat to keep the water as vapor so that there's no condensation in the flue, and the flue has to be big enough to handle the volume of gases produced. There are two main systems, the room sealed and the open. You'll learn about them during the course. For our demonstrations, we'll use an open flue. Once the system's in place, the most important thing to do is test it. To begin with, have a look at it to see that it's not obstructed anywhere and that it is in fact complete. Make sure that it's serving only one room or one appliance and that its terminal is correctly sited. If it's a chimney, check that it's clear and that it's got an adequate rubble catchment area. Any dampers or restrictor plate should be removed to leave the main part of the flue clear. You can now do a flow test. You may have to fit a closure plate. Close all the doors and windows in the room, turn on any extractor fans and introduce some heat into the flue by using a blowtorch, for example. If extractor fans are present, smoke tests should be done with them both on and off. You should note that a tumble dryer ducted to the outside is an extractor, as is a cooker hood which uses the same method. A flow visualization check now lets you see how the flue is performing. Make sure that the smoke is discharged only from the terminal and that there's no spillage into the room. If smoke comes from the wrong terminal, or if there is no flow, the system has failed. It must be checked thoroughly before another test is run. If everything's okay, you can now run a test with the appliance connected. Again, close all doors and windows and switch on any fan which might affect the flue's performance. Turn the appliance on at full rate for about 5 minutes. And remember to test with extractor fans both on and off. Next, do a spillage check using a smoke match, puffer, joss stick, or mirror. Check that the flue's working at the draft diverter or the gas fire canopy by introducing smoke. If there's any spillage, leave the appliance working for another 10 minutes and then recheck it. If there's still a problem then, the system needs to be disconnected and repaired. Spillage is recognized either by smoke being blown back into the room or condensation on the cold mirror. Only when all of these tests have been successful can you leave the appliance connected to the flue system. However well sealed a room is, air always manages to get into it. This is called adventitious ventilation, and it's enough to allow complete combustion of heat input up to 7 kilowatts of natural gas. But if combustion above that level is needed, there has to be additional ventilation, and that means installing permanent ventilators. Permanent ventilation means exactly that. Closable windows or ventilators won't do. Neither will hit or miss grills. As the installer, it's your responsibility to make sure that there's adequate permanent ventilation. If you don't, that is an offence. Ventilators can be fitted directly to the outside on windows, doors or walls. They can also vent to the outside through suspended floors which have underbuilding vents. Remember that a room-sealed appliance takes its air from the outside, so no ventilation is needed for combustion. If the appliance is fitted in a compartment, there are extra precautions to take. Ventilators then have to be fitted at both high and low levels. And before deciding on the type and size of ventilator to fit, you'll need to calculate its effective area to make sure that it's suitable for the room or compartment in which you're fitting it. You'll find details of how to do that in your manual. There's a lot to remember, but don't worry, it's all in your Open Learning Course package. In this unit, we're considering pressure and flow. This equation shows how pressure is measured. It's equal to force exerted over an area. If we put figures to it, we see that a force of 100 newtons acting on 1 square metre would create a pressure of 100 newtons per square metre. That's 1 millibar. This is a data badge. You'll find one on every appliance, and it tells you its correct working pressure. But what is working pressure? Well, when there's no gas flow, the pressure is called standing pressure. When the system's turned on, that pressure provides the energy which causes the gas to flow. It drops slightly, and that's the working pressure. So working pressure is taken with the appliance on and standing pressure with it off. Pressure is controlled by governors. Modern governors usually keep on operating efficiently without needing much attention, but they should be checked during routine maintenance of appliances. They only need readjusting if the heat input to the appliance has to be altered. The adjustments to working pressure should be made in accordance with the manufacturer's data badge. A faulty or incorrectly set governor is a serious matter. The working pressure will be wrong and the result will be bad combustion. This is why the appliance governor's working pressure must be checked during any servicing or maintenance. There are a lot of complex processes involved in all these controls. Pressure is simply force exerted on a particular area. But we've seen how important pressure setting can be for the effective and efficient operation of appliances. When it comes to domestic installations, there are obviously lots of things to consider and lots of safety rules to observe. The type of meter fitted will depend on the flow capacity that's needed, how much gas is going to be consumed, and whether it's a credit or prepayment customer. A correctly installed meter must be level and well supported. The governor should be as close as practicable to the meter inlet. And if the electricity meter's within 150 millimeters, that's 6 inches, of the meter you're installing, fit a non-combustible partition made of insulated material between them. It's crucially important to guard against electric shocks and all the possible consequences, so fit cross-bonding very carefully. Cross-bonding is the bonding of all services to the house earth system. Connect it to the meter outlet pipe no further than 600 millimeters, that's 2 feet, from the meter. If at any time the meter has to be disconnected, temporary continuity bonds must be fitted. All domestic installations must display a permanent notice near the primary meter saying what has to be done if there's a gas escape. If the service pipe supplies more than one primary meter, and if it's possible to do so, put up details of how many there are and where they're situated. And finally, when secondary meters are installed, again note how many and where they are. Pipework in a well-designed installation shows 5 clear features. The right materials have been used in construction, it's well routed, it's clearly and correctly labelled, there's a good gas flow, and pressure is maintained. Once the system has been installed, it's ready to be tested. There are 2 main reasons why installations have to be tested for soundness. First, because a faulty installation could cause accidents, and second, because it's illegal not to. Before the soundness test, though, let's first see how to read a manometer or U-gauge. It's very simple. By holding it vertical, with your eyes at the same level as the water surface, you can take a reading of the pressure that's being exerted on the water column. Surface tension holds the edges of the water higher than the central part. That forms what's known as the meniscus. You take the reading in millibars or inches from the bottom of the meniscus. First, you check that the gauge is in good condition, filled with clean water to the 0 position, and that it's free of air bubbles. And that's it, ready for use. To use it, you just position it vertically, connect it to a gas pressure point with good rubber tubing, and slowly let gas into the gauge. If you're too quick at this point, the surge of gas may blow the water out of the gauge. Now you can read off the level. Make sure that both limbs of the gauge read the same. If they don't, check that the gauge is vertical. If it is, it's possible that you didn't zero the gauge properly. They're essential and very flexible pieces of equipment. They're used for locating partial blockages, identifying inadequate pipe diameters, identifying when a meter is overloaded, checking governor pressure settings, and testing for soundness. Testing for soundness is an obvious priority. If it's an existing installation, the gas supply can be used for the test. But if it's a new installation, you'll need to pressurize it with one of these, a test T. It'll allow you to feed air in and observe the pressure increase at the same time. When you're doing this test, make sure that all appliances and pilots are off and that there are no pipes with open ends. To begin with, you should test for let-by. That means releasing the pressure in the installation to 0 and testing for 1 minute with the emergency control off. There should be no rise in pressure. This is the test for soundness. Next, slowly pressurize with gas or air to 20 millibars. Wait 1 minute for the temperature to stabilize, then 2 more to test the installation for any leaks. If it's a new installation, there must be no drop in pressure. If it's an existing installation that you're testing, consult the British Standards tables of permissible pressure drops for pipework not wider than 28 millimeters diameter copper. Once the U-gauge has been removed, the meter test nipple replaced, and the emergency control turned on again, you test the meter inlet with leak detection fluid in case lockup has occurred. Lockup is the term used to describe back pressure closing the governor valve. Remember, it's standard procedure to test any joint you've disconnected, then reconnected for any potential leaks. This also applies to test nipples. If there's a meter available, the pipework should then be purged to make sure that all the air's out of the system and that the gas is flowing in all of the pipes. First, tell the customer what you're going to do. Ventilate the premises and put out any naked lights. Make sure you don't use any electric switches or appliances. Choose a purge point as far away from the meter as possible. but not one that's in a confined space. When you're sure that everything's safe, purge the system with a volume of gas at least 5 times the badged capacity per revolution of the meter mechanism. If the badged capacity is 0.071 cubic feet per revolution, for example, 5 revolutions will show 0.355 cubic feet. And when you've finished, remember to test all purge and pressure points with leak detection fluid. We've looked at the course itself and the modules you'll be working through: combustion, flues, domestic installation, pressures, flows, testing and purging. It seems like a lot, but you've now got time to go through it all at a more leisurely pace. Remember, though, that there are very strict regulations which stipulate what you can and cannot do. Making sure that gas installations are safe is essential, and in the end, it's in your hands. This has been the first program in this series. Future topics will include domestic central heating, design, installation and maintenance, and domestic central heating fault diagnosis and rectification. Thanks for your attention, and good luck.